All right, so let's review a little bit from yesterday. So let's go ahead and we'll do this one quick. Okay, so it wants us to graph this complex number. So remember, this -5 is the real part, -3i is the imaginary part. So when you graph that, you go to -5, so 1, 2, 3, 4, 5, and down 3. So we're right here. It wants you to draw a vector. So a vector is the arrow. So that is our point and vector. And then in 2, it wants you to find the absolute value. So remember, the absolute value of a complex number is the length of the vector. So with this triangle, if we make a right triangle here, let's go over to 3. We can use Pythagorean theorem. So this is length 3, this is length 5. So you can take 5 squared plus 3 squared equals c squared. 25 plus 9 is 34. So that length would be the square root of 34. Okay, so that was just a review from yesterday. So let's move on to our stuff from today. All right, so it's talking about algebraic properties of complex numbers. So go ahead, pause the video, read through this. So what we are going to do, number 5 says the numbers 0 and 1 are additive identity elements. So additive and multiplicative identity is what you need to know here. So identity means that you are going to add or multiply a number, and when you do that, you get the same number out. That is what identity means. So for example, if you take 0 plus r, you get r. So 0, I'm going to write this over here. So 0 is the additive identity. And then if you take 1 times r, you get r. So 1 is the multiplicative identity. And this is nothing new. You learned it way back, I don't know, middle school probably. So this is asking you, is there an additive identity? So that means, can you add something to a complex number and get the exact same complex number out? So when you do this, can you take a complex number? So this, fill in the blank. This is some complex number. And if you add it to x plus yi, and actually to make your lives easier for understanding, let's just change this. Let's change this to 3 plus 2i, and change this to 3 plus 2i. That'll be easier for you to think about, I think. If you want, you can use what was originally there, that's fine. So can you put some complex number here plus 3 plus 2i and get out 3 plus 2i? So the answer is yes, but you have to figure out what to put in here. And the next one is there a multiplicative identity? So can I take, okay, so we'll switch these again. So 3 plus 2i. So is there some complex number that you can put in here when you multiply it by this, that you get this out? The answer is yes, there is, but I want you to find it. Okay, so that's 5. 6. Okay, so this says every real number has an additive inverse. So additive inverse means that, so if you take a number and you add another number to it, you get 0. So that's for additive. Multiplicative inverse means you can take a number times your original number and get 1. So that is the multiplicative inverse. So for additive inverse, you want to add something to get 0. Multiplicative, you want to multiply something and get 1. So we are talking about complex numbers, additive inverse, so let's go ahead and change these again. So can you come up with some complex number where if you add it to, we'll keep the same thing. What did I put for that one? 3 plus 2i. 3 plus 2i. So can you take something here, add it to this, and get 0? Again, the answer is yes. You have to come up with it. This one, okay, this one is definitely the most challenging in your investigation. So it wants to come up with a multiplicative inverse. So that means, can you come up with something here where when you multiply it by 3 plus 2i, you come up with the answer of 1? Okay, so yes, you can. So what a lot of people will want to do is take 1 over 3 plus 2. Oh my gosh, that scared me. My door just slammed. Sorry. So can you take 1 over 3 plus 2i? Well, if I take this times this, you end up with 3 plus 2i over 3 plus 2i, which is 1. But what's the issue with this? You cannot have an imaginary number in your denominator. And we had talked about how to get rid of that. So I'm going to let you mess with this to figure out what goes in here. Okay, so these next ones, 7 and 8, are actually not bad at all. So it talks about commutative operations. So commutative just means that, so in addition, you could do, oh, it's written right here. A plus B is the same as B plus A, and AB equals B times A. But with subtraction and division, it's not the same. So if you take A minus B, it's not the same as B minus A, and same with division. So for this one, it says, is addition of complex numbers commutative? So all I want you to do is just come up with an example. So come up with something for this. So I could put 2 plus 3i. Here I could put 4 minus 2i. So do this and see if that is equal to, when you flip it, so is that equal to 4 minus 2i plus 2 plus 3i? So as long as you come up with an example and show it works, that would be fine. Or it doesn't work. You're going to do the same thing for multiplication, the same thing for subtraction, and the same thing for division. So if you want to use these two complex numbers for that, that's perfectly fine. Okay, and then on the back, it talks about associative operations. So associative just means that you're moving around parentheses. So you have 3 things. So here we have A, B, and C. So if I take A plus B, and then I add C to it, is that the same as taking B plus C and then adding A? So in when you're not doing complex numbers, that is true, and the same with multiplication. So if I were to take A times B and then times C, it's the same as taking B times C and then A times that. But in general, with subtraction and division, it does not work. So you have to see if it works for complex numbers. So I will come up with just some things you can try it with. So like for this first one, let's just do 2 plus 3i. For the second one, we can do, and again, you don't have to do these. You can just do it with the variables if you would like. I just think it's easier to look at if you are using actual examples. For this one, let's do -3 minus 4i. And then the last one, let's do, I don't care, 4 plus 2i. So all you have to do is, so you're going to add these first two together, see what answer you get. And then I actually left a bunch of room down below, so you can actually show your work there. Anyway, so you're going to add these two together, get an answer, add this to it, see if that is the same as, so these are parentheses, so you have to do these 2 things first. So see if that's the same as adding these 2 things together, getting an answer, and then adding that to it. Here you're doing multiplication. So this one will take a little bit more time because you're multiplying, essentially you're multiplying 3 binomials together. Subtraction shouldn't take long. And then division, that one will take a little bit of time as well. Okay, so that is your investigation. When you are done with this, you should be able to complete OIO page 220, numbers 6, 8, 9, and 10. 6 is one that you could have done yesterday if you wanted. 8, 9, and 10 are ones that you should be able to do now.